I'm going to use yellow, brown, and green. What? I don't use brown a lot. Yellow shows up really well. And then between yellow and brown, red kind of looks like brown sometimes on the camera. So I didn't want to choose red or orange. So green is my next favorite color. Actually, green is my favorite color. Alright, and then if you want highlighters out, I might use 2 highlighters as we go because I tried to use colored pencils last period and it didn't work out great. So I'm going to also use some highlighters. Alright, here we go with the first part. We have a couple of vocabulary words today, and then it's really more vocabulary than it is examples. Excuse me. But it's going to be great. Alright, for our first vocabulary word, we have comparison property of inequality. Comparison property of inequality. All right, what the comparison of inequality, it's something that we all know is true. We just maybe haven't taken time to actually write it down and think about it. Okay? What the comparison property of inequality says is for any 2 numbers, A and B, there are 3 options when we compare those 2 numbers. One option is that A is greater than B. So remember, this symbol means greater than. That's one option. When I say give me 2 numbers, your first number might be bigger than the second number. What's another option? It might be less than this. The first number might be less than the second. And there is one more option. Either the first number is bigger, the first number is smaller, or what? Equal to. All right, so just as a reminder about our inequalities, who can give me 2 numbers where the first number is bigger than the second? 16 is greater than 8. All right, what would work for this next one, or less than? 742 is less than. I want it to be less than something else. So it's not less than 25. That's okay. Let's do like 1,642. So if you have money, who has more money?
You want the $700 or you want the $1,000?
You want the $700? Okay, then I'll take the $1,000. All right, and then what about like 3 is equal to 3? So we could play this game all day where you give me 2 numbers and I could categorize every time which category it goes into. All right, next up we have our transitive property.
Hopefully you remember that word a little bit, transitive. We have talked about it before.
Okay, if I know Layla is the same age as Kennedy, and Kennedy is the same age as Uba, what do I know about all 3 of them? They're the same. So what about Uba and Layla? They're the same age. This still works with comparison. Okay? So, if I'm shorter than Olivia, okay, you see? Okay, now if I compare Olivia and Mohammed, what do I know about Olivia and Mohammed? Who's shorter? Olivia. So if I'm shorter than Olivia, what do I know about Olivia and Mohammed? Olivia's shorter. What do you know about me and Mohammed?
You're shorter than me.
Are you sure? Sure I'm shorter than Mohammed?
No.
Okay, but are you sure? Yeah. I'm not taller than Mohammed? No. Because if I'm shorter than Olivia, and Olivia, thank you, Mohammed and Olivia, and Mohammed is shorter, if I'm shorter than Olivia, Olivia is shorter than Mohammed, that means I have to be shorter than Mohammed, because out of the three of us, who is the tallest? Mohammed. Who's the shortest?
You.
Me. Okay, that's how that works. So if A is less than B, and B is less than C, so if A is smaller than B, but B is smaller than C, which one is going to be the smallest out of all of them? A is the smallest, and we know A will be less than what's the biggest? C. Okay, all of a sudden I don't get to be taller than Mohammed. I would love that someday in my life. Just for one day, I just want to be tall. The rest of my days, I'm okay with being short. Just once. It just would be like fun, just to see. But like, it's not just about being tall. I want to like be proportionate. Like I want long arms and long legs for a day. Slinkies. All right, here we go to our next thing. Miss Sartor's gonna be passing out a piece of paper.
This has two triangles on it. You should not have to cut it out. We can glue it in and do our practice work right next to it without needing to cut it out. But you will need some glue.
Okay, this is the exterior angle inequality theorem. Inequality is the part that's new today. And like Miss Sartor said, you should be able to just glue. You could probably leave your glue out. We're going to use it in just a moment with another thing. So you can glue that in. You do not need to cut it. You're just going to glue it in as it is. And you're labeling this part exterior angle inequality theorem. Give you about 20 more seconds to get that glued in. Share your glue. There should be 2 glue sticks per bin. If there are not 2, let us know and we can keep another one. No, there's glue in it. Oops. All right, for our exterior angle inequality theorem, which angle is the exterior angle here? 1, 2, 3, or 4? 4. Okay, 4 is my exterior angle. Now, we talked about this in our warm-up. Our exterior angle theorem says that 4 is equal to what? What are the remote interior angles? 1 and 3 isn't remote because that's connected. Remember, remote means far away. So 1 and 2. Okay, so because we know that angle 1, or the measure of angle 1, the amount angle 1 is equal to, plus the amount that angle 2 is equal to. When we add those together, what do we end up getting? Angle 4. If you want to color code, you can. So let's think about that. If I add two numbers together and it equals a different number, what do we know about that number it equals? Does that number have to be bigger or smaller than the numbers we used? Bigger. Because if I'm using positive numbers, because angles have to be positive, if I do 5 plus 17, what's 5 plus 17? 22. It's going to get more. If I take a number and I add more to it, I get a bigger number. So I know that angle 4 has to be the biggest number. Between those three. Now notice, which angle am I not comparing it to? 3. Because in this picture it does look like angle 4 is bigger than 3, but do I know that for sure? No. Okay. So because we know this, then what we know is we know that measure of angle 4 is greater than the measure of angle 1 and the measure of angle 2. And again, if you want to color code that, you can. So the outside angle is bigger than the two remote interior angles. If you want to write that this is the outside angle, the exterior is greater than the two remote interior. The outside angle is greater than the two inside angles, two remote inside angles. All right, we're going to do an example with this. If you want to label it, you can. I'm just going to write example because it's kind of goofy. We're going to use this example. I want to know what angles are less than angle 7. So I want to make a list of all the angles less than angle 7. So first thing we're going to do is locate angle 7. Where is angle 7? Is it an inside angle or an outside angle? Outside, so it's an exterior angle. And we know the exterior angle is bigger than the two remote interior angles. So I need to identify which triangle are we going to be looking at where 7 is on the outside. MKL. So the smaller one? MKL. So if I look at this pink triangle, what are my two remote interior angles that would be smaller than this exterior one? You guys are just crushing it back there at that back table today. Okay, so 7 is my outside angle. I want to look at the two inside angles that are further away from 7. They don't end. I'm going to ignore this other triangle for now. 4 and 5, yep, which Yusuf already said, but we're going to pretend that he wasn't so smart right away. So 4 and 5. Now, on your practice today, that will be as simple as it is. You just have to identify that. On this example, it's a little bit more complex, because 7 is also on the outside of what's the bigger triangle it's on the outside of? JKL. It's on the outside of this bigger triangle too. JKL. Alright, if it helps, you could redraw that below. So I have JKL. Here is angle 7. It's on the outside. I want the two remote interior angles. So what angle is by angle J? 1 by K. It's actually 2 and 4. And so since I have to add 1, 2, and 4, I'd have to add all 3 of those together to get 7. We know 7 is bigger than all 3. So 7 would be bigger than angle 1. And 7 is going to have to be bigger than angle 2. And we could list angle 4 again, but we don't need to. If you want to highlight that so you know where our answers came from, that one came from the first one, the pink triangle. These two came from the orange. Alright, I'm going to flip to the next page soon. Make sure everyone's got that written down. We have one last theorem that we're going to talk about today. Alright, our last theorem we're going to talk about today is called the angle-side relationship theorem. Angle-side relationship theorem. Alright, what we know angle-side relationship theorem is that the biggest side of a triangle... I went to the next page, yeah.
Okay, if you have enough room, you can say that I'm the same, but we're going to do some examples with it too, so you might want to.
So the biggest side of a triangle is going to be opposite of the biggest angle. Another word for opposite that we might use is across. And same thing goes with the smallest. So smallest side is opposite of the smallest angle. So you might use the word opposite, or as we work, you might think that you like the word across better. Ms. Sawyer just handed out a piece of paper. You can go ahead and glue that one in underneath. Again, you do not need to cut it. You shouldn't need to cut it, so go ahead and glue that one in. I'm putting it right underneath this. Again, you don't need to cut it though, just make sure you have it in the right direction. So yours should look something like this. Miss Snyder just passed these ones out, so pass those glue around. If you don't set your table, let us know. We can hand more out. Alright, when you come back from lunch, we'll finish those 2 examples. Those examples are really important. On this one, we are going to list the sides and angles from least to greatest. Alright, list the sides and the angles from least to greatest. So we need to do both the sides. What are you guys talking about?
Oh, no Christmas present.
I want to be friends with you guys.
Forget about your Christmas bonus for tomorrow.
Yeah?
You owe them money.
Alright, list the sides and angles from least to greatest. So even though in this one, what are we given? What do we know? The sides or the angles? The sides. Even though we're given the sides, we also have to say the angles from least. And we're going to be using the angle-side relationship theorem. So we want to go least to greatest. So we're going to start with sides. I'm going to just start with the numbers. What is my smallest number we have? 11. So 11 is less than. What would go next? 18. And 18 is less than what's the biggest? 19. So as we list those sides, to name the sides, when it says list the sides, that means the names. So what's the name of the side with 11? ZY is less than my 18, ZX or XZ, either way, which is less than, what's the 19? XY. Alright, now for our angles, we need to go across the sides to find those angles, the opposite. Okay, so our smallest side is ZY, that's the 11. So if I look at this 11, I want to go across the triangle to the opposite angle. So if I go across the triangle, I end up at angle X. So the measure of angle X will be the smallest because it's across from the smallest angle. Or sorry, across from the smallest side. Okay. 18 is ZX. I want to go across from the 18. If I go across, will I end up at X, Y, or Z? Yeah, Y. We want to go across. We want to not think about which one it touches, like which angle is not connected. In that case, it'd be angle Y. Doesn't look very good when I color it in. It's hard to read, so I'm going to just underline. And then 19 was my biggest. That was my largest side. That was XY. So if I look at 19, which angle would be across from 19? Angle Z. Okay, so first we're going to order the parts that we know, and then we'll match it up with that part that's across from it, that's opposite of that side, or opposite of that angle, to go in the same order from least to greatest. All right, we have one last example here. Again, we're going to do our sides and our angles. So we have our sides and our angles. What are we given to start off with? Are we given our sides or are we given our angles? Angles. How do I know that these are angle measures? They're inside kind of the corner, and what else? Degrees. Good. Angles are measured in degrees. Do we know all the angle measures? No. Which one are you missing? W. How can I find the angle W? Okay, we can do 28 plus 78 is 106. I don't know. Do you have a calculator open? 106. So angle W is 106. That would be if it has an outside angle. We know that these all add up to. So 180 minus 106. Oh. 74. I don't think 74. Isn't that 64? It's 74? 74, you guys are right. I'm wrong. 74, I don't know. Just have to question you sometimes. Just have to make sure you don't.
You're questioning the calculator? Why you don't get your Christmas?
I don't know. That's why I don't get my question. Alright, we're going to go least to greatest. So are we going to start with our sides or our angles? Angles, the ones we know. So let's start by just listing them in order with numbers. What's my smallest angle? 28 is less than 74. And my biggest, 78. Alright, and then we're just going to match those with the actual names of the angles, because when it says list the angles, we want to know the actual names of the angles. So what is the angle at 28? UWV V. So we're going to say measure of angle V, that amount, so that's why we have the measure there, is less than, what's the amount, or what's the angle at 74 degrees? W. Which is less than the angle across, or the 78 degrees. I can't. U. Alright, now our goal is to go across from these angles. So to go across means we want the side that doesn't touch the angle. So if I look at 28, I'm looking at angle V. What side doesn't touch V? VW, WU, or UV? WU. We go across. It's the one that won't make contact with it. So for my smallest side, I know my smallest side will be WU, because it's across from the 28. Next up we have 74. 74 is my W. So I want to go across. I want the side that does not touch W. VU. Or we could call it UV. And then lastly we have 78, which I'm going to underline because it doesn't look nice when I color it in. 78 going across would be VW. So even though we don't know those amounts, we can still put them in order of least to greatest. We don't know how long they are, but no matter how long they are, we know WU will be the shortest side, and VW will be the greatest side, the biggest side, longest, if you will.